Good day, everyone. Today I'm excited to take you through the IGCSE Cambridge Chemistry syllabus. So whether you are a student who is preparing for their exams or whether you are a teacher who is guiding learners, this presentation is essential because it gives you a clear breakdown of the key topics and essential study tips for success. Right. So as you all know, chemistry is the study of matter, and matter is anything that occupies space. So in order for you to understand matter, its properties, and how substances interact, this is where chemistry comes into play. So in the IGCSE Chemistry syllabus, there are three key sections that are of fundamental significance that you have to know like the back of your hand. And these include, number one, the principles of chemistry, number two, inorganic chemistry, and number three, organic chemistry. I hope we are still on the same page. Right. So let's look at the structure of the IGCSE Chemistry syllabus. This syllabus is designed to test your theoretical knowledge, your practical skills, and application of chemistry concepts to real-world scenarios. So let's break it down, right? So the first part is the principles of chemistry. So the principles of chemistry part is a foundation part, because for you to be able to build a very strong and rigid chemistry structure, you need a very solid foundation. And this is where the principles of chemistry come into play. So under the principles of chemistry, we have, number one, the states of matter, right? You are supposed to know about the solids, the liquids, and the gases. You are also required to know about the kinetic theory of matter. This is a concept that states that matter is made up of particles that are in constant motion, okay? And the motion of the particles is dependent upon the state of that matter. All right, we are going to have future videos where we are going to further elaborate and elucidate those concepts in more detail so that they become palatable to your cerebral hemisphere. So after that, we are going to look at atomic structure and the periodic table of elements. So atomic structure, we're going to discuss John Dalton's atomic theory, and then the subatomic particles, their relative charges, masses, and where they reside within an atom, the protons, the neutrons, the electrons, right? And we're also going to talk about the trends in the periodic table. Right? The periodic table designed by Dmitry Mendeleev is a table that summarizes all the elements. They are arranged in groups and periods. So as we go down the group, as we move vertically down, it's the group. As we move horizontally across, it's the period. All right. We're going to have future videos on that. Today we're just going to elaborate on the structure of the syllabus. And then soon after that, we are going to discuss chemical bonding. All right. Before chemical bonding, we have isotopes, all right, on the atomic structure, the periodic table. As you know, isotopes, these are different atoms of the same element with the same proton number but different neutron numbers. For instance, we have carbon-12, we have carbon-14, right? And then after that, we're moving to chemical bonding. So under chemical bonding, we're talking of how elements, or rather how atoms combine to form molecules, okay? We have the ionic bonding, we have the covalent bonding, and we have the metallic bonding. Then for the other types of bonding, like the dipole-dipole bonding and the London dispersion forces, which are also known as the Van der Waals forces of attraction, and the hydrogen bonding, is going to be discussed further in the AS and A-level syllabus. And we're also going to have videos on AS and A-level chemistry, right? Then the next aspect we are going to be discussing is called the mole concept and stoichiometry, right? Most people shiver as if they've seen a ghost when they hear that word being mentioned, because stoichiometry and the more concept involves a lot of calculations. So most people fear calculations, but let me reassure you that there's nothing difficult in that regard, you understand, all right? Easy things. Astomborgana mafanis and my kid, right now. Takapulachi, DJ Chico Square Pandy place. Some jokes, why kid? Right. So under the more concept and stoichiometry, we're going to look at concepts like calculating relative molecular masses, right? And also reacting masses. The depth of the discussions differ depending upon which particular curriculum you're studying, because remember, under the chemistry, Cambridge IGCSE, we have the core syllabus and we also have the extended syllabus. So for more information in that regard, I advise that you go to the chemistry website, so the Cambridge website, and download the syllabus yourself, all right? Then the next part is called inorganic chemistry. So inorganic chemistry, we're looking at the chemistry of elements and compounds. So the first and foremost important thing that we're going to talk about under inorganic chemistry is the periodic table, all right? So under the periodic table, we're going to start by talking about the group trends and the groups that are of particular importance to us. We have the group 1, the alkali metals, the group 7, the halogens, and the group 8, the noble gases, all right? And we're also going to talk about the transition metals. Right, the transition metals are known for their variable oxidation states, and they are also known for their catalytic properties and their ability to form colored compounds. Right, for instance, we have the Cu2 plus ion, the Cu plus ion, we have the Fe3 plus ion, which is also fundamental in biological molecules, particularly on the structure of the hemoglobin, where heme is the prosthetic group and Fe3 plus ion is the central metal cation. Right. After that, we are going to be discussing about metals and the reactivity series. Right. So under metals and reactivity series, we are going to be talking about extraction of metals. There are some very key metals that we are supposed to understand, like we have the aluminium extraction, you have copper extraction, you also have iron and the blast furnace, etc. And then we're talking of properties and uses of metals. And in addition to that, we're also going to be talking about the reactivity series of metals. So in our future videos, we're going to talk about the reactivity series and the acronym that you're going to be using to memorize that reactivity series. It's called Popular Scientists Can Make a Zoo in the Low Humid Countryside Most Successfully Good. So we have the potassium, sodium, calcium, magnesium, aluminium, zinc, etc., etc. And there are a lot of issues to discuss around that concept. You know, of the displacement reactions, and a whole lot of stuff. So just subscribe to our channel, and then you get notifications of when we will be posting future videos. So it's very essential that you subscribe to our channel, Farmer Media Educational TV. Right now. So we are going, next concept, we are going to look at acids, bases, and salts, okay? So under acids, bases, and salts, the first issue we are going to be discussing is the pH scale. As you know, the pH scale is a scale that ranges from 0 to 14, and the region that's below 7 is called the neutral pH. Sorry, it's the acidic pH. Region 7 is the neutral pH, and region above 7 is called the alkaline. All right, we're also going to talk of indicators, all right? We have many types of indicators. You have the universal indicator solution. We have the methyl orange. We have the bromothermal blue. And then we have the phenolphthalein. All these are different types of indicators that are used in titrations. And also titrations are going to be another subject that we're going to be discussing about. And also the preparation of salts. It's very, very important that as an IGCSE chemistry student, these concepts have to be on your fingertips. You understand? Right. So the next part is physical chemistry. So under physical chemistry, we have energy and rates of reactions. So we're going to talk of chemical energetics. We're going to discuss the exothermic and the endothermic reactions, the delta H negative and delta H positive respectively. The principles of bond formation and bond breaking. And we're also going to talk of energy level diagrams, right? You have to be able to identify what an energy level diagram represents. If it represents an exothermic reaction, you have to identify, because this energy level diagram shows you the energy levels in as far as the reactants and the products are concerned. Then the next issue, we're going to talk of rates of reactions, right? So under rates of reactions, we're talking of the factors that affect rates of reactions, like the surface area, the volume, the particle size, the concentration, the temperatures. All right, we're going to talk of the collision theory. The collision theory in chemistry states that for a chemical reaction to actually take place, substances have to collide with each other, right? And then we also have the catalysts, right? These are substances that speeds up the rate of chemical reactions. We have the inorganic catalysts, we have the organic catalysts. The inorganic and the biological are called enzymes, right? We've got enzymes like Rubisco. Rubisco. Right? Rubisco is a ribulose biphosphate carboxylase oxygenase. Right? Pyruvate decarboxylase. Right? We have my enzymes in digestion, salivary amylase, lipase, pepsin, a whole lot of stuff. Enzymology is actually a big subject. You know, someone can actually study enzymology for 30 years and develop gray hair. And after that, after the 30 years, you would, I think I cover almost like 10% of what is there in enzymology. So, focus is a science because science is so diverse, right? Then, the next issues we're going to discuss is the equilibria, right? So we've got various equilibrium reactions. These are reversible reactions. Of particular importance, we have the Haber process. It's a reversible reaction. We have the contact process, sulfur dioxide plus oxygen, sulfur trioxide. It's also a reversible reaction. And we're also going to talk about what is called the Lou-Chatelius principle, right? So the Lou-Chatelius principle states that if a system that is in equilibrium is disturbed, it will shift in a direction to counter that disturbance. For instance, in the Haber process, we know it's an exothermic reaction. So if we increase temperature, the reaction is going to go backwards. And it's not of economic importance to us because at Sebo Chemicals in Kwekwe, their mandate is to produce ammonia. Their mandate to produce ammonia, so they have to favor the forward directions more than the backward directions. Hence, the chemical engineers' roles are to make sure that environments are conducive for the forward reaction rather than the backward reactions. Right. The next concept is called organic chemistry. Right? Organic chemistry, this is the chemistry of carbon compounds. Right? So we're going to have the introduction to organic chemistry, where we're going to be talking of the alkanes, the alkenes, and the various functional groups. We have the alcohols, we have the esters, the acyl chlorides. All right, the functional group that you have to be knowledgeable on is dependent upon the level of study you are. Right? We're also going to talk of hydrocarbons, crude oil, the fractional distillation. As you know, fractional distillation is a process whereby substances that have different boiling points are separated. Uses of fuel, with many types of fuel that we have. The next part is going to be alcohols, carboxylic acids, and polymerization. So we're going to talk of important organic compounds and their applications. So this is a summary of the syllabus structure. So let's move on to the next concept, which is the examination format and assessment. In the IGCSE Chemistry, the assessment is through a combination of written papers, all right, and the practical exams. So depending upon the board, it can be Cambridge, it can be Edexcel, etc. The structure may include the paper 1 multiple choice, paper 2 or paper 3, which are short and long structured questions, and paper 4 alternative to practical or the practical paper. It depends with the IG, because IGCSE is so broad, right? It's so broad. We have Cambridge, Edexcel, etc. So we're going to have individual videos that are going to focus on individual concepts so that you are not going to be meandering around the jungle of Ogadini, right? So let's look at the next part. How do you prepare for IGCSE exams? So to excel in IGCSE chemistry, these are some of the most important study tips. Number one, you have to understand concepts, don't memorize. Chemistry is about concepts, all right? So ensure that you understand the why behind the reactions. Understand, don't memorize. And then number two, practice past exam papers, all right? You need to be familiar with examination style questions and timing. Because remember, some of the questions are so tricky, they require you practical application to what you have been taught. You have to master the periodic table of elements, right? Learn the trends, all right? Learn the group properties and learn the element behaviors, right? Next concept, work on chemical equations, right? Learn to balance equations and perform calculations confidently, right? Revise organic chemistry thoroughly because in most of the cases, it carries a significant number of marks, right? And then perform practical experiments if possible, all right? Practice titrations, practice tests for gases, right? Practice reaction rate experiments, right? Number four, let's talk about the real-world applications of chemistry, right? Remember that chemistry is not just about passing an exam, right? It plays a major role in fields like medicine. You have drug development and the pharmaceutical industry. It's dependent upon chemistry, right? We also have environmental science. Understanding pollution and climate change. It's also very, very important, right? We have industrial applications like manufacturing processes, food chemistry, and cosmetics. It's also very, very important. So in conclusion, the IGCSE chemistry provides a strong foundation for students interested in science, engineering, medicine, or environmental studies. With the right approach, you can master the concepts, you can ace your exams, and you can apply chemistry in real life. If you have any questions, feel free to drop them in the comment section. This is Chico Squared, the Maths and Science Guru. Asomba mafanis. Chakwenda chibaba icho.